Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Good afternoon and welcome to Do the Math. My name is Mickey.
I'm Scott.
And in studio today we have Connor. And Connor, if someone needs to get a hold of us here at Do the Math, what can they do to get in touch with us?
For math homework, help, call. In Bakersfield, 636-4357. Anywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemath.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right, thank you, Connor. Now, speaking of social media, did you know Do the Math was on social media? Facebook, Instagram, Twitter, and YouTube.
No, I did not.
All right, so there we go.
I only knew it was on YouTube.
So we've already learned about one thing today here on Do the Math, and I'm loving it. All right, so Connor, tell us what grade are you in and what school do you go to?
I'm in 5th grade, and I go to Stockdale Elementary.
Stockdale Elementary. What's your guys' mascot over there at Stockdale?
It's just a big star.
Big star. All
He
right.
smiles most of the time.
Big smiling Stockdale star. Perfect. In 5th grade. And do you just go to that one 5th grade class? Do you go to another 5th grade class? I believe you go to another one, right?
Yeah, I'm in Gates, so on Wednesdays I go to a different class.
Okay, and then there's kind of like enrichment activities or other things like that?
Yeah, we do like work and other things, but sometimes we do something that's fun also.
Awesome.
Like we have these like puzzles that we're supposed to do that are like really hard, but we can barely ever figure them out.
Okay, so it sounds like these puzzles that are really stretching your brain, pushing you beyond some limits that maybe you don't get every day in class?
Yeah, pretty much.
Outstanding. It sounds like it's a pretty good outlet for you, something new? Mm-hmm. Awesome. Well, going off of there, let's look at today's math in the news. Okay, so those of you out there who might have heard of Johnny Appleseed, recently up in Tehachapi, up in eastern Kern County, they had the Apple Festival, October 15th and 16th up there in Tehachapi, and many opportunities up there to do some games and activities involving apples in the different agricultural areas up there in Tehachapi. But if you are not going to make it up there, or you didn't make it up there to the Apple Festival, you can go up here. We go to Pulford's Apple Tree Orchard out there on Highline Road in Tehachapi. And on this bag, it might be interesting. People might think, well, you go pick a bag of apples. Well, there's actually a term for that. It's actually one peck. And a lot of people, what's a peck of apples? It seems like it's just a bag. You know, there's no real rhyme or reason what a peck is. But you notice, you might have heard this saying, a bushel. Many people think, well, bushel's just this name of something, a bushel of whatever it is. Well, a bushel of apples was actually a scientific measurement along with one peck. So looking at it here, there are some different things, and we see that 1 bushel equals 4 pecks. And a bushel is a measure of dry volume equal to 32 quarts, which is 8 gallons. So a bushel is a dry volume of 8 gallons of something. And it measures volume instead of weight. So the weight of the fruit in a bushel, it depends. You know, a bushel of apples might be heavier because apples are smaller compared to a bushel of watermelons, because watermelons take up more space even though they may not be as heavy for the volume. There we go. So it also tells us here that a peck is also a measure of dry volume and is smaller than a bushel, which is why the bag here is 1 peck. And we need 4 of those bags to fill 1 bushel. And if you're wondering, there's some other weird names of measurements out there in cooking in other areas of the world. One of those is a dash. So when I say, oh, add a dash of this, and you think, well, what's a dash? Well, there actually is a rhyme and a reason to what a dash is. It's part of a teaspoon. You might be thinking, well, a part is not really a mathematical quantity there. So as in just a dash of salt. What's a dash of salt? It's between a 16th and an 1/8. So again, there's not an entirely specific quantifiable measurement of what a dash is. However, it is between a 16th and an 1/8. So for those of you cooking aficionados out there, it's really up to you to decide what tastes best in your opinion. We also have a couple other ones. A pinch. Well, you might be watching something and someone says, add a pinch of salt. Well, I don't exactly have the biggest fingers, and other people might have larger fingers or smaller fingers. So a pinch of salt definitely can change how food tastes in your opinion or the cook's. But this one is specifically a 16th of a teaspoon, or it is also half of a dash. So many different terms there. They do interconnect with each other a little bit, but it's a little different. And finally, we have a smidgen. Some of you might have thought a smidgen was an entirely made-up word. I totally thought it was until I came across this. And a smidgen is a real thing. It's half of a pinch or a 32nd of a teaspoon. So if you're in a kitchen or nearby somewhere that has a teaspoon, take a look at that teaspoon and imagine cutting it into 32 tiny little pieces, and that's a smidgen. I'm not sure if we can quantify or if you guys have ever held a smidgen of something. I think it might be a couple grains of salt at that point.
Right.
Scott, have you ever you think a smidgen was a real thing?
I
Connor?
didn't think it was a
Did you
real
know
thing
smidgen was a
until
real measurement?
I didn't even know that was a word.
There we go. Boom. There we go. Found out it was a word, and we all figured out that it's actually a measurement. When I go home, I can't wait to figure out what a smidgen looks like in salt. Maybe I can count the grains of salt. Well, hopefully you learned a little something today with some math, and that's today's Math in the News. All right, going forward. So Connor, 5th grade, right, over at Stockdale Elementary, and division.
Yeah.
How are we feeling on division? Division in class a little bit.
Pretty good.
Okay. What about division with decimals?
Now that we are working on.
Okay, so that sounds like something we can kind of structure today and get you a little more support and kind of maybe advance you a little more. Perfect. Head on over to the board with Scott, and you guys are going to work on some long division. All right, let's go ahead and start. Now, do you know the difference between divisor and dividend, Connor? The actual mathematical names for the numbers in a division problem?
I'm pretty sure divisor is the number that you're dividing, right? Or is it?
Let's try a problem here. How about 675 divided by 5? Okay, first of all, what would you do to this problem if you were going to set it up to get ready to solve it?
Well, what I would do is that I would take apart these numbers, kind of. Well, I would take apart the 600 and the 75. And I would
Or you'd split them up before you even did the problem, huh? You don't want to put it like underneath a little roof or whatever? I mean, it's interested in what you're going to do with this. I like it.
Well,
why would you split them up? Does that make it a little easier for you?
Yeah, it does.
Okay.
Because when you have the 600, it lets you do the 75 easier because you don't have to do the numbers almost instantly.
Gotcha. Okay, so we're going to split this up when you go and solve it. And the question initially was, which one is the divisor in this example?
Now, the divisor is...
What are the two words again? Divisor and
dividend.
Dividend, gotcha. So do you know which is which?
Divisor and dividend? Or is that
It's one or the other, huh?
divisor?
Which one is doing the work? Which one is dividing?
that?
The 5 is dividing, right?
So that would be the divisor?
Divisor, right? And the dividend is the one that's being divided.
Yeah,
Right?
the one that's just
So
sitting
if I
there.
was setting up this problem, I would love to make it look like this, right? Because I want to be able to divide it out. But it sounds like you have a different way of doing it. So why don't you do your way over there, show me what's going on. Maybe I can learn something about a little easier way to do it. So you said you want to go ahead and break it up, right? 600, okay.
And then the 75. So what I do is count in my head how big these numbers are.
Okay.
So you have to do 120, 120 to get 600.
Whoa, so tell me where that came from. Now you're exactly right, and I like the way your brain's working. That's wonderful,
Because-
but how did you do that?
Well, 12 times 5 is 60.
Okay, so
do
maybe
you-
you're looking at this 600 by not looking at the 0,
Yeah.
right? You're just looking at the 60. So 60 divided by 5 is 12, I agree. And then what happens with the 12?
I add a 0 behind it.
Add a 0 because the 600 has a 0 on the end. Okay, gotcha. So next to the 600, 600 divided by 5 is 120. I agree with you there.
Divided by 5 equals 120.
And so we're breaking things down into smaller parts where you don't have to do some long, fancy, complicated dividing, right? You can just do the things a little bit in your head. I like where this is going. All right, keep on going. What do we got?
Well, I know that 75 divided by 5 equals 15.
How do you know that?
Well, I've done this math before.
Okay, all right.
So
So you're going to do 75 divided by 5 now. Good.
1, 5.
Good. So is the answer 120, 15?
No, it's 135.
Okay, so how do you know how to add those at the end then? It sounds like that's what you're going to do.
You just, when I do.
Like
I
at
do-
the end of this problem, how come you don't multiply those together? How come you don't subtract them? Why do you add them?
Because you take apart these numbers, add them together, and
Gotcha.
you're basically just adding these two.
I like the
by
way you
lifting it
think
up.
there. Yeah, that's exactly it. So when you broke this down into two parts, instead of finding two numbers that multiplied together, you found two numbers that added together. And I agree, 600 plus 75 is 675.
Yep.
So if you added the two beginning parts, you have to add the two end parts as well. I agree with that. Go ahead and add them up for us.
So that would equal 1, 3, 5.
Gotcha. Now, are you really confident about that answer?
Yes.
How confident are you? Like, would you bet $1 on it?
Kinda.
Would you bet $5 on it?
No.
No? Well, let's make sure. We want you to be as confident as
Yeah,
possible.
I'm actually pretty confident. I might
Okay.
bet $5.
Would you bet $100 on it?
I don't have that much money.
Let's see if we can check this out just to make sure that you're correct. How would you check this answer?
Well, you could do it your way by.
Could do it my way, but that's still dividing. Is there a way you can take your answer and make it go right back to the beginning?
You could
Like
count by 5.
if you started off with 135, how would you get back to 675?
You
Or
would-
try to?
Well, I would. Some people would add it, which takes like forever.
That could take a long time, right?
Yeah.
But
But-
what's the opposite of division?
Addition.
Opposite. We want opposite.
Wait, I mean times.
Right. So if you went opposite of 135, right, you came up with the answer,
Yeah.
and you multiplied it back by 5, you should get 675. Can you work that out for us real quick?
Well, that of course would equal. Well, we already know the answer, but
We do know the answer, but we want to check to make sure that really is the answer. Can you multiply that out for us?
What I would do is that I would add it, like make a bunch, like 5 of them, and then I would add them together.
Gotcha. Can you multiply it? Is it possible?
Yes, it is
Okay.
possible.
Can you do that for us? Because I like to see the opposite of the division part.
Let me just do. I'm gonna do it. How?
You like that 135, huh?
Yeah.
Well, the good thing is we're going to be able to see what it really means when you say 135 times 5. You're going to have 5 of them, right?
Yep. This might take a little while. All right, so all I have to do is, so 5, 10, 15, 20, 25. Put the 5 down there, add a 2 up there.
Good.
So 3 plus 3 plus 3 plus 3. 1, 2, 3, 4, 5. So 5 times 3 equals 15.
Uh-huh. Plus 2 more, right? Don't forget to add that 2 in
Oh
there.
yeah, no, forget to add that. That equals 7.
Mm-hmm.
And so adding.
You going to carry that one?
Yes.
There you
and
go.
you'd put it right there. So that would equal 1, 2, 3, 4, 5, 6.
Hey, it worked out pretty well. And it's the same thing that would happen here, right? 5 times 5 is 25. You carry your 2 just like you did.
Yep.
5 times 3 is 15, plus 2 is 17. Carry the 1 just like you did. 5 times 1 is 5, plus 1 is 6. And that's a good way to check to make sure that your answer really does make sense. And of course, we have a long way that you could multiply or you divide it out as well. So lots of different ways to come up with the same answer. And that's what I always like to remind my students. There's always more than one way to get to an answer. Even though math a lot of times has the right answer, there's more than one way to get there. So nice job on that one. Good
Well
point.
done, gentlemen. Come back over. Nice job. It looks like we have a couple different ways of doing not only dividing. I know that's not a way that I was typically taught
Right.
in school, but it's definitely a new way of looking at division, breaking it into pieces.
Yep.
I'm wondering later if we add decimals, if that method will kind of maybe run into some problems, or if we're ready to go and try that out. But for now, Connor is ready to say thank you. We want to send you over to our friends over at Grillin' Burger to go have a meal on Do the Math as a thank you for coming in and doing the math. You ever been to Grillin' Burger?
Yes, I have.
Are you a fan?
Yes, I have.
Excellent. All right. Well, there you go. When you go on in, let them know you're here from Do the Math and that you got to do a little math today. But for now, we're going to head on out and explore the tools of mathematics out at the Hot Rod Garage with John. John, take it away for us.
I'm John, and we're back in the Do the Math Hot Rod Garage talking about the tools of mathematics. Our dragster and drag racing is nothing but mathematics. Everything on our car is a measurement, is a calculation. Let me show you one of the tools that we use on a regular basis. To keep our car running properly and to keep it tuned up, we've got to make a lot of measurements, and some of those are pretty precise. Let me show you one of them that can be a challenge. This is a spark plug that we're going to run in our Hemi. One of the critical measurements is this little gap in between the electrode and the ground strap. It's the gap in between the center electrode and the grounding strap that a spark of electricity will jump across when the engine fires. That spark of electricity is going to ignite the fuel-air mixture in each cylinder and make our Hemi run. That's what's going to make the power, is that spark. That distance between the center electrode and that ground strap is critical to our engine running properly. The manufacturer wants us to have an 18 thousandths of an inch gap right there. Let's try and measure that gap. If we take a conventional tape measure, well, that's not going to work very well. Our tape measure doesn't hardly fit in there, and it's not graduated to thousandths of an inch. No way am I going to get an accurate reading on that. I can try dial calipers. That's another tool of measurement. It's graduated to the thousandths of an inch, but I have a hard time getting the end of my calipers in to the gap. That's not going to work either. We've got a very elegant and simple solution to our problem. It's today's tool of mathematics. It's called a feeler gauge. All a feeler gauge is a series of pieces of metal that are ground to an exact thickness. The thickness in thousandths is engraved right on the piece. So I'm assuming that this is going to be about 24 or 26 thousandths. Let me go and find the 26 thousandths blade. Put my glasses on so I can see a little bit better. It's bright out here at the Hot Rod Garage. Here's 26 thousandths. Let's see if that's the gap of the plug as we received it. Oh, it is. This 26 thousandths feeler gauge just makes it in between the electrode and the ground strap. It's telling me that that gap is 26 thousandths. That's never going to work for a race car. We've got to reduce that gap. We've got a tool to do that. We can take the spark plug and place it in this tool. This tool will let us take and bend our ground strap closer to the center electrode. We're not just going to guess on that. We're going to take our feeler gauge, set it to 18 thousandths of an inch. Got to go and find the 18 thousandths. There's 18 thousandths. I'm going to set that right inside our gap so we know when this is bent, it's 18 thousandths. Squeeze it down to bend that gap. We're bending that electrode down now. Take it out. Perfect fit. We've now gapped this spark plug to 18 thousandths of an inch using a simple tool of mathematics, the feeler gauge.
All right, and thanks out there to John out at Hot Rod Garage. And I don't know if he would measure a spark plug gap with a pinch or a dash or a peck, but it sounds like that feeler gauge gives him a much more accurate measurement to make sure his hot rod is running high and tight and ready to go down that track as fast as he can. Well, welcome back into the studio, though, here at Do the Math, and we have Erlinda with us. Erlinda, thank you so much for joining
you're welcome.
us.
Thank you very much.
And Erlinda, we have Connor, Mickey, myself here, and you're from Boys and Girls Club, from what I understand.
Correct. I'm the area program director out at Boys and Girls Club, meaning I oversee a couple of sites throughout the year. I'm a little new to that position, so fully taking that on, learning. Just here to talk about what we do at the Boys and Girls Club.
Awesome. Well, take us through, what do we have here in front of us? I see petals around the rows, but I'm not seeing anything related to flowers or botany or anything.
That is okay.
There.
So on a daily at any of our clubhouse sites, they are doing a variety of things from arts and crafts, science, STEM, which is what we have here. Brought a game over called Petals Around the Rose. This is something that the kids will utilize for our STEM club. Each of the clubhouses have the STEM club, so small groups of 8 to 12, they will work on math-related skills, but in game form. So it's that disguised learning that they're doing. So this is one of the games, an example of what they might do. So what we have here is you will try to figure out what the pattern is to get a specific answer that I'm going to give you. Make sense?
Okay,
so on the first one, it is a little tricky. I tried it out. It took me a little bit, but it's all the fun in that disguised learning. So on Item number 1, your answer is 8. You're going to try to figure out what the pattern is to get to that number. So you're going to look at the graph here. This is going to be your rows. Your petals are going to be the outside. So if there's anything in the middle there, that's going to count as your stem. So you're going to try to figure out how we add those elements to get to that number, that magic number 8 for that number 1.
What do you think, Connor? You notice anything? I'm going to hand you the pencil. You seem to be on this already.
So,
what do you notice?
Do we add like these parts or these, or do we add them all together?
So you're going to add the petals, which are the surrounding parts.
So these 4 out here,
anything with the
2 on the
rows,
outside.
yes, the stem, we're not going to add that. The stem is any dot on the die that's in the middle. So you're going to add up the petals around. I gave you the first answer, but for the other 3, I'm not going to give you the answer.
All right. So you would basically just like, you would kind of X out those. If
Yes, so you're only going to count the ones with the petals.
So you would, it's basically 2, 2, 2, and 4, 4 kind of.
So keep in mind, we're only adding the
So
ones
do these
that
ones
have
have
the
stems,
petals.
Connor? Remember, the stem is going to be
We're
the
not
dot
gonna-
in the middle.
Oh, so we're not
We're
going
not
to
going to use those guys.
Ah, good catch.
2 and 4.
So we're not using those because there are no stems in the middle.
So if need be,
These
cross
ones,
those guys
cross
out.
them out. If they don't have a stem, we can't use them. So this one doesn't have one. Very good. Does this one have one?
No.
Nope. Then cross that out. No stem there. But these 3 all have stems, don't they? And then they have the petals on the outer corners. How many petals do you notice are there in total around the stems?
There are about 8.
About 8 or exactly 8?
Exactly 8, really.
Exactly 8, yes.
That's that magic number, so that's the correct answer for number 1. I gave you
right,
the
let's
answer,
give an
so we
8 there.
verified
Nice job.
on how we got the 8. So for number 2, I'm not going to give you the answer, but we're going to do the same pattern, use the same formula, so to speak, on how to get that answer. Let's see if you can figure that out.
Noticing
got
this,
the answer
this
here.
one doesn't have a stem inside,
stem,
so
okay.
we would X
Get rid
this
of that one,
out
okay.
and X this out.
Okay.
So this would probably equal 9 because, wait, no, this would equal 6.
Correct.
Because you don't count these in the middle.
So do you want to go ahead and circle the way that we figured that out? Circle the petals that you did count, which are your outside, correct? Correct. You got it.
Boom and boom.
Okay. Do you want to
Bada
try?
boom, there we
do you
go.
wanna
Let's
try
see
number
that
3
third
just
one
for
there,
fun?
Connor. Take it away.
This one's 0. Not 0. Because it, oh wait.
Number
oh,
3, are you sure on that one? So
Oh wait,
look at them.
I accidentally got confused with the other ones.
You're good.
So that would equal 25, of course.
Are we sure? So keep in mind, we're
Right, hang
only
on.
counting the petals.
Oh wait. Oh, that's just 20. This is 20. This is 20.
Are we sure?
Why 20?
Yeah.
What makes you say
Because you don't count this part, and this would equal 4 on each one, and 4 times 5 equals 20.
20?
Ding, ding, ding.
There we
All
go.
right, you want to write that one? And then what do you think about that last one?
Now that one is 0.
You got it, 0.
Nice
So I read a
work.
little fact here saying that Bill Gates had a difficult time finding the solution to this.
Ah, so even a man as talented as himself.
There
It
you
was
go.
still just an interesting look at what is a rose, what is a petal.
Yeah.
And I think we have a minute or two. Connor, I want you to go ahead and come up with one pattern.
Oh, we actually got a
And
couple.
see if Erlinda and myself can come up with the answer.
Oh, actually, 2 different sheets, but go ahead.
Go for it. So go ahead and make one up, and we will do the best that we can to solve it.
So it could be 7 on here.
However you want to make that happen.
Or we can use the
So-
dice. If you want to roll some dice, you can also put those down that way.
Ooh.
So you can
I do
roll
wanna
them for
try
your
that.
last couple there. So go ahead and roll. Let's see. All right, we got
That's a good way to do it.
2 and a 3. And your last one looks like a 6.
Last one, 6.
Yep. All right, take a moment. Make sure you know the answer before we try it out. But don't go touching it, though, because it might give it away to us.
Yeah. All right.
All right. All right, Linda, what are you thinking here?
Okay, so we're only counting the petals that have the stem in the middle.
Okay.
And when we say petals, we're meaning 1, 2, 3,
The
4,
outsides.
the outside 4
Right, the outer
corners.
ones.
So
Okay.
if I were to have to get an answer for this, I would say 8.
That is incorrect.
That's incorrect.
Incorrect, he says. I'm counting 1, 2,
Wait, hang on.
3, 4, 5, 6,
So we're
7,
only
8.
counting the 4
I'm counting
corners.
10. So only the corners count.
Only the corners,
Oh, okay. So these middle ones here are kind
Yep,
of
those guys don't
tricksters.
count a little bit.
Okay, so 1, 2, 3, 4, 5, 6. Okay, so it looks like 8 also. Connor, is that what you're thinking now that we know the middle one?
Yeah, those ones don't count.
Nah. Yeah, just
Only
those,
the 4
just those
outer
4
corners. All right.
Well,
So when explaining this as a group activity, the staff member in charge of that would give all those, okay, this is how we're going to figure out. These are the pedals, the stems, this is what we're going to utilize before they jump in.
Okay.
Yeah,
Now, if someone
1,
wanted
2.
to join the Boys and Girls Club or to get involved in the STEM mentoring program, give us a little bit, what is it and how does someone join? Or if someone looks to be a volunteer and maybe enhance your program, what's one way people can get in contact?
So the first step would be going to the Boys and Girls Club of Kern County. Go to bgckc.org. Go there, or they can call the club 661-325-3730, inquire, and anybody answering the phone can direct them to the correct area. If they're going to the website, there are the program tabs for after-school program, for day camps, for nutrition, for volunteers, for careers. All those things are on the website.
Okay, now not only with STEM mentoring, but as far as I've heard, Boys and Girls Club also offers during the breaks, winter break, fall break, summer break, you guys offer some programs. Do you guys have one coming up here fairly soon?
Yes, so anytime we call them non-school camps, so that would mean fall break, winter break, spring break, summer break, to provide services for the kids to be in a safe, fun, engaging environment. So our closest one coming up is Thanksgiving break that runs November, I want to say 21st through 23rd, Monday, Tuesday, Wednesday. Our day camps are all 7 a.m. to 6 p.m. A lot goes on during those times. Breakfast is provided, lunch provided, afternoon snack, and throughout the day, the kids will rotate to different activities, arts and crafts, STEM, science, game room, gym, field trips go on. So there's a lot of different things going on during those day camps.
Well, it sounds like even if students are out of school for their learning, there's still lots of learning to be done here at the Boys and Girls Club.
Absolutely, all day, every day.
That's outstanding. Erlinda, thank you so much
You're
for
welcome.
coming in. We really appreciate you having us. And let's put that flyer up on the screen one more time so everyone at home can see that. If they're wanting to get more information on Boys and Girls Club, their autumn extravaganza. There we go, November 21st through 23rd. Looks like you have 3 locations, no matter where you're at, always somewhere. Boys and Girls Club in your neighborhood to help you out.
Yep. And that website will direct you to all 3 of those camps.
Awesome. Erlinda, thank you so much again.
Now, who
we're going to
wants
head out to
to- now,
C-Tech, though. We'll come back. We'll head out to C-Tech to their fashion merchandising, and we'll see what the folks out at C-Tech have going on today.
To what? To get a new one?
I teach fashion merchandising and retail sales. It's a class where we're looking at everything from beginning stations of fashion, and we'll take students to look at things like their fashion portfolio. We're going to look at principles and elements of design. Students need to understand color, line, shape, and texture. They need to understand balance, proportion, emphasis, and rhythm. And they need to understand all the design elements so that they have the core foundation for fashion. So they have to draw croquis, which is your fashion sketches. They have to make sure that they understand rendering, which is kind of coloring in 3D, so it sells a market. They understand tech packs or technical sketches, so that's what goes to the pattern maker. And then they also have to understand math. You know, there's still math in fashion. A lot of people think there's no math. You still have to cost for a profit, but they do presentations in this class. We also work on communication skills. They're selling, they're involved in fundraisers. And so my students are selling items outside, whether they're doing fundraisers for like food sales, or they're selling, like here, they're selling charms and beads and so forth.
I think it's a really good program, especially if you're even if you're a little bit interested in fashion or think about maybe wanting to pursue fashion sometime in the future. It's a good first way to kind of get a look into fashion and how things work, how to do it, and it's a nice introduction, especially if you're planning to go to fashion school too. It gives you FITM credits, so when you go to FITM, you don't have to take certain classes because you've already learned the knowledge. So we learn a lot of good curriculum and stuff for beginning. I think the best part is meeting all sorts of different people and seeing everybody's different designs, because everybody has their own style and has their own collection, and it's crazy to see how everybody can learn the same knowledge but use it so differently and create all these different looks. So it's really cool because I feel like nobody in the class has the same designs. Everybody's different and everybody has their own specific aesthetic.
We actually get the statistics and like the right learning of it, and we also get the hand-on and touch experience. Like we get to do mannequins and then draping and then touching fabric and learning different textures and textiles. I would recommend others to take this class if they are passionate about it and if they want it to be in fashion.
Well, I've always enjoyed working with students, so teaching and then fashion has always just been fascinating because it's multifaceted. It's not ever boring. You know, it changes. It's art. It's creativity. It's a business, and you're looking at history. And anytime you look at all those, you put them together. It just makes it a unique, experience to work and teach students. Some of our business partners locally here, we've worked with Lori Brucker, and Lori Brucker she was a fashion designer in New York, and now she's like a business consultant where she does a lot of work with Tejon Outlets or the Valley Plaza and so forth. And so we have some students job shadow her. We've worked with some of the businesses like that have the bridal shops and so forth. And then we also have a lot of the retail shops, all the shops at the plaza and all our vendors. And so if anything ever comes up, then they, have the students come out to, help them out.
And thank you to those folks out there at C-Tech. Amazing every time to see what those students come up with, making their own videos, doing their own voiceovers, and even to see fashion merchandising. A lot of students may think fashion merchandising is just selling something, but it's also designing it. How do you put it out there electronically for someone to see? Because I know I can't go into the store all the time and try everything on that I think I might like, or online there might be more variety. Yeah. So amazing to see the folks out there at C-Tech giving those students those great hands-on skills and knowledge to make sure they're ready for the 21st century workforce. But until we go back there, let's head to the board. Let's do some more division, gentlemen.
To the board.
Okay, what are we doing this time?
Oh, I believe last time we were looking at just long division, but we had two different ways of doing it. Let's see what happens if we make a decimal in our dividend.
Gotcha. Okay, so what happens here if we have 721, that's a 1, divided by 5. What are you going to do with this one? Do you plan on splitting it up like you did before?
Well, you can't really do it completely, and there's no remainders, so because you have to you can't have a remainder because this is the decimal one, of course.
Gotcha. All right. So what are you going to do with this one?
All right. Well, we would make decimals, of course.
Okay, let's do it.
All right. So it's 1.
Do you know when we set it up like this and have the 721 underneath the little house there, do you know how to do it that way? Because I set it up last time and you had your own way of doing it and it was awesome. I love the way you did it before. But if you had to, could you do it this way?
I mean, you could. And this is a tricky one.
It is a little bit different. The question is, could you do it this way? Or would you rather do it a different way?
I could do it that way.
Okay, let's see it. I'll help you through it.
Should I make the decimal a half decimal?
We don't have a decimal yet. No decimals yet at all. Because so far, we don't even know if it's going to work out evenly, right? I know you're thinking ahead and going, it's not going to work out evenly, but that's okay. We'll get there. What would you do if you were just going to try it?
I would try to do it my way, kind of. So that's what I'm going to try at least to do.
Okay.
5 and wait. Five. So I would take it apart, of course. So we just make it 7. Okay.
Hooray for erasers in math, right?
Yes. Hooray for erasers. 7, 0, 0, and 2, 1.
Gotcha. So you're adding those together, and you can divide those out separately?
Yeah.
Let's see what happens. What's 700 divided by 5?
700 divided by 5. So it would be 14, of course,
Why? Where did that come from?
because last time, well, it was 75 divided by 5. It was 15. So take away the 0 right
Oh,
here.
so we want to get rid of the 0 again. Okay, so 70 divided by 5. That's what you're saying. That's what you're doing in your head?
Yeah.
And what is that?
14.
14. Okay.
Because you would be taking away a 5 from the 75 from last
Okay,
time.
so 700 divided by 5 is what you're saying here. This is 14, and you're going to bring that 0 right down, right?
Yep.
Gotcha.
so it would
Okay,
be
what about
100.
21 divided by 5? What do you do there?
Now that, it would normally be 4, but
Okay.
we're going to add a decimal.
So if you divide this by 5, you'd have 4 with a little bit left over, right?
Yeah.
And you're going to put a decimal there? Gotcha. So what we have left over, one of the ways you can look at this is we have 1/5 left over. There's a fraction is what we really have.
So
Can you
we'll-
change 1/5 to a decimal? Do you know how to do that?
You would like do 4.5, I'm thinking?
Not quite. It's not a half. That would be a half, right? Do you know what 1/5 of a dollar is?
1/5, that's 25.
Not quite.
Wait,
Almost. That's 1/4. He's thinking. I like how those wheels are turning. Awfully close.
A dime,
No, a little bit higher than that. 2 dimes. What's 2 dimes?
20.
Gotcha. So that's 4.2. So what we'd like to have happen is 4.2, right? Because that's 1/5 of a dollar, and you can add those together.
So 140 plus 4.2, that would equal 144.2.
Gotcha. There it is.
All right, now
So
let's
the way that you've done
verify
it-
with that long division. Let's
I
just
like
walk
that.
through that one also.
Sure.
Yeah.
And if you're used to doing this the long way, what I would call the long way, but the way that I certainly learned how to divide, 5 goes into 7 one time, right? 1 times 5 is 5, and we can do some subtraction. That's supposed to be a 5, promise.
Looks like a 6 kind
It
of.
does kind of, huh? Yeah. Hooray for erasers. And we'll bring that 2 down. 5 goes into 22 4 times, so it looks like we're getting pretty close. 5 times 4 is 20. And we subtract, and we bring this 1 down here. 5 goes into 21 another 4 times. And 4 times 5 is 20. We subtract, and we have this 1 left over, just like we had that 1 left over right here. We don't like to have that remainder at the end. So
we do
here's the
not.
way you can change it if you're doing this long division, okay? Where is the decimal on the number 721? Because every number in the world has a decimal, even if you don't see it.
Right there.
Can you put it there for me?
So it would be a 0, right?
No 0. Don't add any numbers yet. Just tell me where the decimal is.
Right here, I believe. Well,
Put it on
actually,
there. That's it. That's where the decimal is. Where's the decimal on the 5? That's it. If you don't see a decimal on a number, it's at the very end. Good job. So what we can do is
Like a period.
we can add a 0 at the end of that number
Yep.
because it doesn't change the value because it's after the decimal. If it's before the decimal, it would change the value significantly. But it's
Yeah.
after the decimal, so it's not that big a deal. So now we have one more number to bring down. This 0 can bring down here. Getting a little messy here, but I tell you what, there is nothing wrong with messy math. I promise you. How many times does 5 go into 10?
That would go in 2 times.
2 times, that's right. And 2 times 5 is 10, and now we end up with a remainder of 0. Now what you do have to remember is, since you put the
Yeah,
decimal
add an
here, you got to make sure that decimal goes right up there, right?
Yeah.
That's it. Yeah, you have to go right up there in your answer. And so we end up with the same answer that you have, which is kind of a good deal. I like that part a lot. Now, given what you showed me last time about how you check the answer, how could you check this answer? Because the way that I would check it is 144.2 times 5,
Yep.
and hopefully you get back here. Do you want to add up 144.25 times?
You might.
That's the way you did it last time, right? And I like
Yeah,
that.
that's
That's kind
what
of
we
nice.
wanna do.
How would you check this answer?
Well, thinking about it, this would equal a 20 instead because it's the decimal. It would be an actual 20 because this should have a 0 behind it.
You could.
Like,
You
if
could or
add a
not.
0
Either way.
It's supposed to have a 0 behind it because if it doesn't have any number left, and it's just a 2.
But you could also have 4 more zeros and it wouldn't change it either, right? So all those zeros don't really matter. But if you like to have a 0, then that's okay. So how would you check it? How would you multiply 144.20 times 5?
Well, how it would be is like 5 times 20 is 100.
All right. Can you write that
So,
down?
5 times 20 is
Uh-huh.
and we would want to add the 1
Oh,
right
then you're
there.
going to carry the 1. Okay, gotcha.
So 5 times 144. Now that one is easily a 721. Well, actually, it's 720 to be exact. But adding the 1 to that would equal 721.
So you want to do the whole 144 times 5 all together, huh?
Yep.
Man, there's a whole bunch of math going on in your head. I like it.
But it would normally be 720. But if you didn't add that 1, then it would.
And if you were multiplying piece by piece here, 5 times 4 is 20, plus 1 more is 21, right?
Yep.
5 times 4 is 20, plus 2 more is 22,
Yeah.
and 5 times 1 is 5, plus 2 more is 7.
And then you get that.
There you go, 721. So now the decimal and the zeros that you have, can you tell me if these two values are equal? 721.0. Are those two things equal to each
Yeah.
other?
It doesn't matter how many zeros you put, like you said.
So you could also have 721, right?
Yep.
And so all those values are equal, and that's why the 0 that you added here at the end of this number here could be useful, but it's not necessary either, right? You can either drop those off or you can have them on the end. Either way it works. This would be a number we'd probably see more like on a cash register,
Yeah.
right? And this is the number we kind of want to come up with because it was the same number we had in the beginning. But either way, we get a chance to check that answer to verify that your work was good. Nice job on that problem. Well done.
Thank you.
All right, gentlemen, we have time for one more problem before we head on out of studio again. Let's check out another decimal problem and see how it goes.
Uh-oh. So should we start one with the decimal in the problem first? Oh, look at that. You know what? We were just talking about some money, so let's go ahead and see if we can do a money problem.
Dollars.
Yeah, and we like dividing by 5 because I like the way that works in your head, but we're going to change it up just a little bit here. What if we have 3, 2, 1, $321
All right.
and 6 cents.
And 6
And we're going to divide this by 3.
by 3.
Yep.
Now
How would you go about that problem?
is tricky.
It is, yeah. Got a little bit of work going on there. How are you going to attack that?
Well, I would always take it apart like I always do. So I get 321, just like the last problem.
Gotcha. Can you put a plus sign between those two so we don't forget?
Beep.
There you go. We got to make sure we have them separated out. Good. Anything else? What about the 6 cents? What are you going to do with that?
Well, you always would. That normally would be 6 cents. This would be 0.03 plus 0.03.
That's definitely true. All right. Let's see what else you want to do. You're going to divide everything by 3? So everything in this whole column here, or sorry, in this whole row, everything divided by 3. All right, one at a time. Here we go.
All right. That would equal.
So what's 300 divided by 3?
That's 100.
Can you write that below, please?
This might take a little
Yep, that's why I had it right there for you. 300 divided by 3 is what?
1, 0, 0.
Good. What about 21 divided by 3?
Now 21 divided by 3.
And remember, we're going to put that plus sign, so I'm going to bring this plus sign down here for you. What's 21 divided by 3?
Well, that actually is, that would be 8, I believe.
Almost. Close.
7.
Yep, that's it.
All
So
right.
going to put 7 down there.
7.
Okay, good. And then again, we're going to do a plus sign. So what's 0.03? Or in other words, 3 cents. What's 3 cents divided by 3?
That's 1.
It is, yeah. 1 cent, right? Can you write that 1 cent right here and make sure you have the decimal in the right place?
Beep
Yep.
and beep and
Good, and we got to do it one more time, right? Because we have one more here.
boop, beep, and bam.
Good. All right. Now your job is to add them all up so we actually have one numerical answer at the end. And don't forget that numerical answer will have a dollar sign.
Well, that's 100 plus 7 is 107.
Okay.
And 100, 0 point, hang on, 0 point, hang on, 0.01 plus 0.01, that would equal 100, hang on.
Okay, so we're getting close.
7.
107. Good.
0.02.
Gotcha. Can you make sure that's in the right form? Because again, we're talking about currency.
So that, it's kind of like that part right there. The decimal sign's right there.
That's right. So, but where's your dollar sign?
Oh.
Where are you going to put that? At the beginning? That'll work. So at the very beginning, we got to make sure we have a dollar sign. So what is the final answer if you had to say it in words?
$107.02.
Hey, you know what? I learned something today because that's certainly not the way I would have done it, but that's exactly right. Great work today. I like how you did that. That's good.
Well done. I can tell you, teaching 6th grade every day, that's not a method I've heard of or seen, but it's definitely something, if it works for you, I'm excited to bring it back to my own classroom.
That's right.
And see how other students take that.
Yeah.
And you never know. Someone may really enjoy it and can work out math much more easily. So
Goes right back to what I said. We always want to get to that final answer, but there's multiple ways to get there.
absolutely. Gentlemen, well done. Take a break. While you guys are taking a break, we're going to head on out to NASA Science Cast and see what's going on out at NASA.
Humans have observed many wonders across the cosmos. Yet much of our universe is still shrouded in mystery. Among those mysteries is the formation of our universe, which should have resulted in a balance of matter and its corresponding counterpart, antimatter. Much of that matter is thought to exist in the form of dark matter, which can't be directly observed. Much of the antimatter can't be found at all. Studying fundamental particles originating from sources up to billions of light years away may hold the key to understanding both the composition and history of our universe. Welcome to the world of particle physics, currently being explored from low Earth orbit by the Alpha Magnetic Spectrometer, or AMSO2, installed on the International Space Station, or ISS. Planets, stars, interstellar gas, dust. What we're able to observe across the universe comprises less than 5% of the total content found throughout the universe. The other 95% is dark. Dark matter as well as dark energy. Dark matter doesn't interact with or produce light as far as we know. It doesn't consist of normal matter, or matter that can be observed directly. So how do you improve understanding of something that can't be observed? One way is to look for evidence of its interactions. Kurt Costello, the ISS program chief scientist at Johnson Space Center, explains how the giant magnet of AMSO2 is working to help scientists test and modify their theories. Scientists are using AMSO2 to look at cosmic rays, charged particles that travel near the speed of light. AMSO2 categorizes each cosmic ray, looking at a high energy range to see whether that stellar phenomena that we can measure can account for all of the cosmic rays we're seeing. But if you see something in the spectra that doesn't fit, then this could be evidence of dark matter interactions. By studying cosmic rays, scientists are also able to search for antimatter. The Big Bang theory of the universe's origin requires a 50-50 ratio of matter to antimatter. But to date, the amount of antimatter found doesn't come close to matching the amount of matter known to exist. Costello says one of the goals of the mission is to detect antimatter and see if there are any large collections of it out there somewhere. When particles pass through the strong magnetic field produced by AMSO2, their paths bend. Antimatter particles stand out because their paths bend in the opposite direction compared to matter particles. The instrument searches for antimatter with a sensitivity 3 orders of magnitude greater than the original AMS, which flew in space in June of 1998 aboard the Space Shuttle Discovery. This could support the discovery of antimatter pools that were previously undetectable. A key factor in our ability to get the most out of AMSO2 is time. Originally expected to have a lifespan of 3 years, the instrument has continued to perform into its 8th year of operation aboard the orbiting laboratory. In late 2019 and early 2020, astronauts conducted a series of spacewalks to replace AMSO2's cooling pumps, which were failing. Extending the life of the instrument will provide scientists more time in their quest to unveil some of the universe's greatest mysteries. For more on scientific studies being done on and from the space station, go to www.nasa.gov/ISS-science. For more information about the origins of the universe, visit science.nasa.gov.
welcome back in the studio here at Do the Math. Thank you for NASA giving us that amazing footage to see just exactly how the universe might have started and the theories behind it, but it doesn't necessarily match up today a couple billion years later. Always interesting to see what kind of new knowledge NASA has out there for us, and hopefully they continue to get more in the future. But until we get back out to NASA, let's turn to the boards and keep going with some division.
All right, Connor, how would you approach a problem like this? We saw in one problem where you had two whole numbers and you had a decimal in the answer. And then we had a decimal in the first number, and now we have a decimal in the second number, right, in the divisor. How are you going to go about figuring out a problem like this? Any ideas how to attack it?
No.
Okay, well, this is something to learn then. Here we go. What the wonderful thing is about division is if you want to make this look like a problem that I know you can do, right? Wouldn't it be nice if we could just make this divided by 5 instead of 0.5? Because if you were dividing by 5, it'd be a little more straightforward, and you can certainly use your method, right?
But it would have like a remainder, kind of.
It's not going to have a remainder in this problem, and I'll show you why. This problem here, okay, with this divisor, 0.5, we're going to change into 5. So that decimal has moved over one position, right? But if you move it over one position just for your convenience, which is what we've done here, you have to move this decimal over as well, okay? If that decimal starts there and it moves over one place, what is the new number?
3,120.
Can you write that in front, please? That's it. And here's my example for you real quick. Do you agree that 1 plus 2 is 3?
Yeah.
And if you multiplied everything by 10, would it still be true? What's 1 times 10?
10.
10. What's 2 times 10?
20.
20. What's 3 times 10?
30.
Is that still true? It's still true, right? So if I multiplied every single thing in this problem times 10, it's okay. And the same thing happened here. All we did by moving the decimal over one place is we multiplied both of those things by 10. You can't just do one of them. You got to do both of them. So can you do that problem? And he says, yes, I can, right? How would you do that problem? You'd like to split it up, I bet.
Divide it in 3.
Oh, you're going to divide it in 3 points. Okay, gotcha. 3 parts. The first one is what?
3,000.
3,000, okay. And then what's the next part?
100.
Okay, good. Good job. I like how you're going about this. All right, what's 3,000 divided by 5?
So it would be.
So in this case, we're going to cover up 2 zeros, right?
So it would be 6 normally.
Okay. It would be, because 30 divided by 5 is 6. I agree with that. And you can take those 2 zeros and put them right there, right?
And you get a 600.
All right, what's next?
100 divided by 5. That's 20.
Okay, write that down next. And then we're adding in the last piece. What's 20 divided by 5?
Well, that one is easy. Ooh, that's 4.
Okay. Good. Can you add them all together for me? Good. There you go. Gotcha. So what would you do to see if you could check this answer?
You would, of course, add the times.
Well, again, we can take this 624, right, times 5, and you can multiply it all back together.
Yeah.
That doesn't seem to be your method, though.
I
Your method's a little
normally
different. What would you do?
I would draw 624 5 times.
Yeah.
And then add it.
Can you do that for me? And while you finish up those numbers, Connor, what do you have against this way of doing it, man? I like the way you do it.
I've never done it before.
Here's the reason I really like the way you do it, because you can see what's going on behind the math. I really like that a lot. And so sometimes I think students, at least students that I've had in the past, they see this problem here and they can do it, but they don't really know what's happening. And you're really showing us, right? What this says is 624 5 times. That's exactly it. Okay. Let's see what happens.
So 4 plus 4 plus 4. So that would equal 20 normally.
Okay.
So add a 2 up there.
Good.
2, 4, 6, 8, 10, 12. That's a 12.
Good.
So putting a 2 right there.
Okay.
6 plus 6. 6 times 5 is normally 30, but adding a 1 equals 31, of course. 3 and
Can you make that 2 into a 3? There you go. Nice job. And we're back to here where we started, right?
3,120.
3,120. Now here's the interesting question I have for you. Look back at the original problem, right? We're not really back to the original problem. We're back to the modified problem that we made so that you didn't have a decimal in your divisor, which I think was a really good idea. How do we know that that really is the answer to this problem?
You add a 0 right behind the decimal.
Well, that'd be kind of nice, but we do want to get back to where we were. Tell me if you can do this problem. The answer that we got, right? What is the final answer? The answer that we got here is 624, right? 624 times 0.5. Now again, that's the way I'd like to do it.
62.4.
But how would you do that?
Well, you would, of course, I would add it
You would add it,
0.5
right?
times.
Now, how would you do that? How would you add 624 0.5 times? That is a tough one, isn't it? Yeah.
Well, you would put a decimal right there.
You could put a decimal here and get rid of that one. Would that be the same thing?
I mean, no, it wouldn't.
We're really messing with stuff now, huh?
Yeah.
Because if you had a decimal all the way down here and you had 62.4, then you would have 312.0 and you'd be back to where you were, right?
So we would get 62.4 as the answer.
Last question I have for you. What is 624. What is 312 times 2?
312 times 2. 624.
What the heck? So 312 divided by 0.5 is the same as 312 times 2. That's kind of interesting, huh? You know that 0.5 is the same as 1/2. Would you agree?
Yeah.
Right? Okay. So 312 divided by 1/2 is the same as 312 times 2. And why is that? Because when you divide by fractions, you have to multiply times the reciprocal, right?
Sounds like you guys are getting a lot done over there.
Got a lot going on
A lot
there.
going on, even with just a little decimal work. Connor, come on over. As we wrap up the show here, I want to check. Did you learn something today?
Yes.
Did you have a little fun?
Yes.
Would you want to come back on? Awesome. Well, until that day comes around, you can always be a Do the Math ambassador. So you'll be able to go around at school and show everyone that you were on the show today and you are now a television star, my man. Did you have some fun today?
Yes, I did.
Awesome. And until we see you guys again, continue
Wait,
to
and
do
before
the
I
math.
leave, I have a shout out for my teacher, Mr. DeMarco.
What's your shout out? Just saying
You're a
hey.
very good teacher, and I'm very happy that you're mine.
All right, there you go. Until we see you guys then, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.